Section 3.1 is all about solving system of equations. System of equations I'll affectionately refer to as SOEs by graphing. Solving system of equations by graphing. Now, first of all, what is a system of equations? Well, a system of equation is two or more equations grouped together. Two or more equations grouped together. Now, we've solved equations, but what happens is, suppose we had an equation like y equals negative 2/3 x plus 4. Now, we can't solve this by on its own because it has two different variables. What we could do is, since there's two variables, we would need two equations. So, another equation would be y is equal to x plus 9. This is a system of equations. Now, oftentimes they're grouped with this little curly bracket thing that I'm terrible at making, but you get the sense of what's going on there. These are two different equations, and we're going to solve this system of equations by graphing. Now, get out some graph paper. I'm going to insert mine. Oh, yeah, you get to see my fish and stuff. Anyways, let's graph this. Now, if we were to graph this first equation, the y-intercept, b is the point 0,4. So we plot the point 0,4 with a slope of negative 2/3. Now, with the slope of negative 2/3, what I would recommend doing is make a ton of points. Make as many points as you can, going to the right and also going up to and right 3. Up to and right 3. That's going to give us a bunch of points. And then get a straight edge and draw your line through it. Yikes. Alright. Then we're going to graph the other equation. Before we do that, let's go back to all these points that we made. All of these points are solutions to this first equation. Oops, I didn't mean to delete that. All these points are solutions to this equation. If you took the point, for example, 6, 0, negative 2 times 6 is negative 4. Negative 4 plus 4 is 0. See how that is a solution. Now, let's graph this other equation. Our y-intercept is 9, and our slope is 1. Let me just go up 1, right 1. But positive slope, let's go the other way. Down 1, left 1, down 1, left 1, down 1, left 1. And you might see what happened there. You can see that at some point we hit one of the other dots from the red line. Sorry, Haley. This one point right here, this is the one point that is on both lines. Both lines have the point, well, what point is this? Negative 3, 6. Negative 3, 6. This is the solution to this system of equations. Both of these lines have infinite amount of points, right? There's all these points. This red line has all these points. The blue line has all these points here. But the one point that they have in common is this point right here, the point negative 3, 6. If you were to plug that in, it would be a solution, or it would work in both equations. Now, let's talk about the possible solutions to a system of equations. Possible solutions to a system of equations. Let's say that we had one like a system of equations similar to the one that we just graphed. We had this red line going like this, and another one going like that. Where is the solution to this system of equations? It is the intersection point. The intersection point is the solution to a system of equation. So this one has one possible solution. The one solution is the intersection point. There's one solution. It is the intersection point. All right, that's one possible way. Now, this can happen in infinite different ways. However, it has one solution. Let's draw another one. Let's suppose that we had a red line with, well, that looks like a positive slope. We had a blue line with, well, I suppose that's a positive slope as well. And what I'm going to say is that these are parallel lines. How many solutions does this have? Well, if the intersection point is the solution to a system of equations, and if parallel lines do not intersect, this system of equations has no solutions because these are parallel lines. Now, if you get one that has no solution, parallel lines, I want you to write that out. No solution, parallel lines. There is a third scenario. Third scenario, Smith, can two lines go and intersect it in two places or something like that? No. But here's the deal. We got this line here. It's got a positive slope. And we graph this other line. It just so happens to be the exact same line. All right, so this would be something like y equals 2x plus 1. And the red line would be y equals 2x plus 1. They're the exact same line. So, and if the solution is the intersection point, how many intersection points does this line have? Not only does it have two, it has all of these are intersection points, right? Even the ones where I don't draw the line very well. These are all solutions. So, how many solutions are there? There are infinite solutions. There are infinite solutions, same line. All right, so the basic nuts and bolts of what a system of equation is all about. This should be review. You graph the system. The intersection point is the solution. If they don't go intersect, there's no solution. And if they're the same line, they have infinite solutions. That's all I got for you. Have a good day.